Welcome back everyone. This video is about building very basic pipeline with option map and option bind. One of the alternate goals or the extra goals I have for this particular session is to give you an insight about what mapping and binding really means. It will definitely take some time for you to start seeing what is going on, why we use bind, why we use map. However, on the surface, both may seem like transformation functions. They are not. So as I discuss some sample code in this particular video, I would highlight what is going on, why map is used in certain cases, and why bind is used in certain cases. Like always, I'll go to the work area, write some code for you. The existing code, the existing sample, which is based on which is the basis of the blog entry, is already committed. You can always check it out. Now, remember we talked about two functions previously: the map function and the bind function. And I mentioned that if you have a container type, and which is option in this example, when you want to transform data, which is mapping, you will invoke a function via option.map. Such a function has input as real data as well as output as real data. So very simple example, let add 2x equals to x plus 2, let add 5 x equals to, let me make it 1. Now it's evident that both these functions, the input is real data and the output is real data for both these functions. So if you have an option called let opt1 equals to some 1, and if you say option dot map add 2 to option 1, sorry, or we can simply print this out for seeing what is happening behind the scenes. So let's see what happens. Okay, so we started with some 1, which means that the container had the value 1 in it, and then option 1 is passed to option.map and add 2 is passed to option.map. What we are simply asking for is, if there is data in option 1, opt1, apply add 2 function on the contained value and return back a new container. And you can clearly see this is exactly what is happening. We passed in a container and the output is also a container. The key thing to notice here is the pure transformation nature of this whole invocation. All we are saying is, if there is data in it, do something. There is nothing beyond that. I'll just quickly pipeline it to make it slightly more richer of an example. IntelliSense and F#. Let me just write it down like this so that you can clearly see stage by stage, step by step. So what we are asking for now is that the output of this should come as the last parameter for this. So this resulted in an option which we already seen, and now option.map mult5 So whatever the option which was produced by this stage becomes the input for this stage, and the output of this stage goes to printfn. So what we are simply saying is we have pipelined to option.map. In one case we are invoking add2, and in the other case we are invoking mult5. This entire thing is equivalent to let stage 1 equals to this, let stage 2 equals to this. From here to here is here to here, and whatever the stage 2 is becomes the input for, or the last input for printfn here. Okay, so pipelining is a convenience thing here. So if we run this, we can see 15. 1 plus 2, 3, 3 into 5, 15. So again, in both the cases, when we are invoking map, add2, mult5, we are invoking functions where there is absolutely no ambiguity regarding the purpose of those functions. These functions are purely performing some or the other kind of transformation. That transformation could be capitalize a string, replace spaces from a string, add something to something, convert a student record to a person record. As long as there is an input and there is an output of real world type, that is, the output is not of container type, you are dealing with mapping functions. Okay, now let's write a simple function where we will have to use binding. And if you recall the previous discussions, you use bind with functions that take input as real data, but the output is elevated container type. So for example, let add to if even x equals to, if x mod 2 equals to 0, then sum x plus 1 else none. What we are saying here is that here is some input, which is integer in this case, real data in this case. We are checking for the even odd nature of it. If it is even, we are adding 1 to it. Why do we need to return sum and none from this function? Because of the uncertainty. The objective of this function is to only perform the operation when the input is even, or an even number. That is what introduces the uncertainty, and no surprises, option container, result, etc. are different ways of dealing with uncertainty. Now you can't use map here, because if you use map, the output of this function is already elevated. Sum in one case, none in the other case. And the way map operates is, as you can see from this example, your function here is returning a regular value, a real world value. But the output of this stage is an option in itself. So option.map, after invoking this function, whatever the output of this function is, rewraps it or repackages it or elevates it back into the container. If you invoke map with this function, you will end up with undesirable double elevation. There are cases where double elevation or double lifted data is needed. That's for later. In fact, there's a whole dedicated discussion I have for double lifted data. But this is not the case. This is the case where you want to start with an integer, end with an option. So we will use opt1 as an example, get rid of this, and we will say option dot bind at to if even opt1, and I'll copy this much, let's see what happens. Now let's guess what the output should be. We are sending OPT1. OPT1 has 1 in it. This condition will fail. So the output of this whole exercise should be none. No surprises. Let's make it 2. Now we got sum 3. So if the input was, and at 2, we should have added 2 here. Let's rerun it. Sum 4. So basically what this function is saying, this particular stage, if there is an input which is an even number inside the container, you will have the next even number of the sequence. That's what it is doing. So now let's use this in our pipeline. Let's start with 1, and also let's make this add 1, 1, 1, and here instead of a map we will do this and get rid of this. Stage 1, get the option, perform a mapping via add1. So X OPT1 has 1 inside it. This should result into 2. Then we are adding another 2. So the answer we should see is 4. Okay, sum 4. If we change this, if we let's say make it 2, this stage will result into 3, and this stage will be meaningless. That's the beauty of pipelining map and bind, that within the pipeline, if at any moment the option becomes none, the rest of the pipeline is, it will be executed, but it will literally be returned, those functions will be returning from the none case, none case, none case, because the input is in none case, the output is none, 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 none. So in this case we are producing sum 2 will become sum 3, and this stage will fail, producing a none. Okay, now imagine after this stage you want to plug in this one. So again, this function is a function which deals purely with non-elevated values. So all you need to do is plug in this function. First stage mapping, second stage binding, third stage mapping, and you can actually simplify all of this by writing it like this. It becomes even more consistent and readable. Here is some output, the pipeline starts, and at this juncture we have print fn, which is not usually what one does. So here is the starting point of pipeline, and here the pipeline has the last stage. Typically you will do something else with the output of a pipeline, but that's not the point of this discussion, so we will see that later. Now let's see, let's run it and see what happens. It's still none, because in the previous example we discussed that this stage will produce a none. So let's change this to 1 again and now see what happens. So now we have 20. Why? Because we started with 1, added another 1, became 2, add 2 if even, 2 is even, added another 2 which became 4, and this stage multiplied it by 5. Now I wanted to pay close attention to where we are using bind. We are using bind with a function that's dealing with, or that's returning elevated data. And this is what you have to understand, that you are not returning elevated data for fun or just because you can return elevated data. These are the cases of transformation. This is the case of transformation which may or may not happen, but this is the case of a trajectory change, a direction change, a branching, and so on and so forth. In your pipeline, you wanted this input, and this de facto transformation. And then you have a moment of uncertainty, like you are on a road, you keep walking for a certain distance, and then you may have to take a left or a right. Another example or another view you may have is an if block in imperative code. Before the if block, there are a lot of statements which are doing things, and then you invoke an if condition, and within the if condition you write the continuation, and after that if condition you may, or within the if condition you may have more transformations, and then you may have another if. So if I do this again, what you are saying is input some transformation, and this stage may or may not change the direction, may or may not take a left turn or a right turn. It may keep going straight, or it may take a left turn. If it is on the success path, if it is on the path you want, this pipeline has some meaning. If it has gone into none, all of this is useless. Again, within this stage, there are like sub stages now. The moment you see bind, you have invoked a trajectory change, and everything after that bind, you should read it as if it is a nested part of it. For reading sake, you can read it like this. Whatever follows this bind, if I have to literally redo all of this, if that's the business need, because all this bind and this bind are causing trajectory changes. Maps can't cause trajectory change. Okay, so there are a lot of fancy words, there are a lot of people have different choices. I stick to binding as in binding. You will see continuations, you will see and then, you will see monadic bind, you will find all sorts of different names or words used for the same phenomena. Okay, so I'll quickly go to blog and see. Yeah, so I have here, first thing I've done is I've tried to explain what I mean by a pipeline. A pipeline for me is a linear flow, at least for my eyes. When I'm reading code, when I'm writing code, I'm implementing a linear flow. Even though I'm invoking branching, that's not my burden. That burden is not mine. Unlike this example where I'm first of all making a check, forcing flow control, some transformation via statement, another check, and again I'm forcing flow control, and so on and so forth. So flow control is something I don't wish to deal with. That should be your goal also, that you implement what you need to do inside small nuggets of pure functions, and then you have bind and map pipelines. And bind and map is two things you must remember. Bind and map is not the only way to build pipelines, and bind and map is not always applicable. There are more functional patterns, there are more functions which we will talk about later. It may get simply overwhelming at this point. You must develop a very strong feeling for map and bind. You must understand it. The moment you see map and bind, you should clearly know what is happening. Depending upon the container, map is a transformer, bind internally may or may not be doing transformations, but it's a point of a fork out, a Y junction, a trajectory change, a decision making point, a continuation, and so on and so forth. So simple examples here is this is exactly what I was talking about. So this is a C# example. This is a bind point because everything else is actually nested. This is a straightforward map point transformation. This is another bind point. I've given this example to visually showcase it, what is happening. In reality, the way option map and bind works is slightly different, but they should give you a decent insight. Here is an example of a full-blown map pipeline where I am here is some input and a lot of lambdas to do transformations, and then using a function to print the result. Same thing, a validation pipeline, given number should be divisible by 2, 3, 4, 5, some input, and in all the cases I'm doing binding because I have to force divisibility by all these numbers. You may read it one condition and other condition and other condition and other condition. So after this, these three are nested. After this, these two are nested, and after this one is nested. So I'll quickly conclude this one now. The objective of map and bind may seem similar. It's not. Map, input real world data, output real world data, and you are dealing with transformations. Bind, input real data, output elevated data. You need to capture some kind of decision making, some kind of trajectory change. When dealing with such functions, the ones that are purely dealing with real data, you use map or map. When dealing with functions that have uncertainty encoded in them, you use bind. In the next one we will make it more complicated by dealing with the result. The result will help you get even a deeper view, a better view of slightly more realistic problem statements. The example or the examples that I talked about in this video are not really practical, they are more academic, but once you see a result in action, you will see you will have a better view. Righto. See you in the next one. Thank you.